Hi everyone, in this video I'll be going through chapter 9 linear law, worksheet number 2. So for this worksheet you'll need 4 pieces of graph paper. Please prepare your graph paper as well as your pencil and long ruler because you'll be drawing graphs based on the examples. Okay, if at any one point of time you need more time, just pause the video to continue drawing the graph and continue playing once you're done. Okay, so for this worksheet, what is the main gist of this worksheet is that you will learn from worksheet 1, you have learned how to convert any graph to the linear form, y equals to mx plus c. So let me highlight this. This is a very important form you must know. Capital Y equals to mx plus c. Okay, whereby your variables are contained within big Y and big X. And from what you have learned, for any straight line graph, it has this equation here. M stands for the gradient of the straight line, and C stands for your y-intercept, but in this case it will be your big y-intercept. Okay, which means your vertical intercept, it can represent any other variables based on whatever equation that I'm given. Okay, so there are some important steps you must follow first. Let me just run through with you first. Whenever the question asks you to draw a straight line graph and the equation given to you is not a linear form, step number 1, to draw the graph, you must first do a algebraic manipulation to turn this graph into a linear equation of the form big Y equals to mx plus c, whereby all your variables are contained within big Y and big X. M and C should just contain your constants. Once you have done that, you need to identify that this is your big new Y vertical axis. This X is your new horizontal axis. Then you need to draw a table of values for the new Y and X axis. Then once you have done that, you will plot the graph of Y against X. Take note, the question always tell you Y against X. It is always your vertical axis against your horizontal axis. Okay, so let's illustrate this using example 1. Example 1, the table shows experimental values of two variables, X and Y, which are connected by this equation over here. Okay, and by A and B are constants. So part 1, using a scale of 2 cm to 5 units on the x square axis and 2 cm to 5 units on the y minus x axis, plot a graph of y minus x against x squared. So if you remember what I said earlier, it is always your big Y axis, your vertical axis against your horizontal axis. This is your big X axis. Okay, so but before you do that first, we follow the same steps. If I look at the equation I'm given this equation here. Okay, this is actually a quadratic equation. If I were to plot y against x, I'll get a curve. So how do I convert this equation into a straight line graph? So let's do some manipulation. Maybe I'll write at the side over here. Okay, y equals to ax squared plus x minus b. Okay, therefore I can manipulate this based on what the question tell me. Plot a graph of y minus x against x squared, which means that my y-axis now is y minus x. So I'll subtract x on both sides of the equation. I'll get y minus x equals to ax squared minus b. There if you can spot very clearly, you can see that now my y minus x, this is your new y-axis equals to your x squared here. This is now your new x-axis. Then your a represents your gradient. Negative b represents your big y-intercept. Okay, so over here, I hope you can see how we can convert this original quadratic equation into now a straight line graph, whereby your y-axis now is y minus x, your x-axis is x squared. Okay, so now I've done that. I've done step 1. I've rearranged the linear equation to the form of y equals to mx plus c. Next step, draw the table of values for this new axis here. So I'm given x and y values. Now I must find for this corresponding x and y value here, what is the corresponding y minus x value and what is the corresponding x squared value. So over here, I'll draw the table of values. Usually I like to draw it in the top right corner of my graph paper, so you can take your graph paper now. On the top right side, usually I write out my table of values here. Okay, x and y is given by the question. I now need to find what is my x squared, as well as y minus x value. So very simply, you can just calculate. When x is 1, x squared is 1. When x is 2, x squared is 4. So correspondingly, you should be able to find the corresponding x squared value. Similarly, for y minus x, when x is 1 and y is 41.5, y minus x is 41.5 minus 1, which is 40.5, 36.0, 28.5, 18.0, and 4.5. Okay, so with that, I've now drawn the table of values needed for this graph question. Okay, last step, table of values, form linear equation done, plot table of values done. Last step, plot the graph. So check the axis carefully here. Now I will draw my vertical and horizontal axis based on these values here. My horizontal axis x squared is from 1 all the way to 25. Then my vertical axis is, the lowest value is 4.5 all the way to 40.5. We follow the question says 2 cm to 5 units. So if I were to plot on my graph paper, I've already done the plotting here. Your graph should look, your out axis should look something like this. Take note, horizontal axis is x squared. Vertical axis is y minus x. Okay? So once you have done this plotting now, I can now plot the points. Based on this graph here, the first point, when x squared is 1, y minus x is 40.5. So on this graph here, I will use a cross to mark out all my points. When x squared is 1, y minus x is 40.5. So that means that over here, my 40.5 should be here. Okay. Then similarly, I continue marking out the points. So you can pause this video and try by yourself first. Mark out all the points needed to draw this graph here. Okay. So very quickly, if I were to plot out all the points, 4 and 36, I should get here 9 and 28.5, 9 and 28.5, here 16 and 18, I should get 16, 18 here. Then 25 and 4.5, I should get here. Okay. So once I've done plotting out all my points, my next step is to therefore draw a straight line that will, a best fit straight line that can pass through all the points. Okay, take note here, this line that you draw should be a best fit line that can cut through all your points where possible. Okay, so based on my graph here, I think my best fit line will look something like this. Okay. Okay, then once I'm done with drawing my line, I will label this equation of this line here. This line has the equation y minus x equals to ax squared minus b. Okay, so this is for drawing the graph. Done. This is part 2 done. Part 1 done. Okay, use your graph to estimate the value of a and b. So if I look at this equation here, a corresponds to the gradient of the graph, negative b corresponds to the vertical intercept. Okay, so over here for part 2, okay, gradient, to find gradient of this straight line, I will take 2 points along this line here, along this best fit line. Okay, so let's say if I choose to take, maybe I can take, over here, I will choose perhaps this line here. Okay, wait, let me, okay, I will take, that's my, okay, I can choose perhaps, I'll take this point here then, here, okay, then I'll choose this point here, then I'll use a dotted line so that I can check what is the values. Okay, take note, you should draw your gradient triangle very clearly. Okay, so choose 2 points along your best fit line, then you can calculate the gradient much more easily from here. Okay, so from here, what do I get? I can see that maybe I can choose this point here. Okay, I do not have a ruler on my iPad, so it's a bit hard to draw straight lines, but you should be able to draw a straight line. Okay, so then I mark out the coordinates of the points I picked. this point here is, let's say, 21. This point here is 21, 22, 23. 23, comma, the y coordinate is 7.5. Okay. Then similarly, for the top point here, I pick the coordinates. I should get this is 2.5, comma 6, 7, 38. Okay, so therefore over here, we can calculate now from here the gradient. I know gradient for, let's look at part 1, part 2. Okay, gradient of the line is simply y2 minus y1, which is 38 minus 7.5 over 23 minus 2.5. Okay, then we can calculate what this is from here. Let me use my calculator. Okay, you can pause this video to calculate this by yourself. Okay. Okay, I should get 38. Okay. Okay, so based on my calculations here, I will get negative 1, oops, okay, did I put my gradient wrongly? It should be 38 minus 7.5 over 2.5 minus 23. Okay, take note of this here. So I should get 2.5 minus 23. It will give me negative 1.4878. Okay, so this means that therefore since A corresponds to the gradient of the graph, A would be simply equals to negative 1.449, round off to 3SF. Okay, take note there is a margin for error here. Usually the final answer is plus minus a certain range, so check carefully, make sure that your graph isn't too far off the actual answer. Okay, then the next part. Okay, I know that the vertical intercept C corresponds to negative B. So based on this graph here, I can see that the intercept here is about 42. This is 42. Okay, so this means that negative B is equal to 42. Therefore, B is equal to negative 42. Okay, this is for part 2. Alright, then now last part B. By drawing a suitable straight line on your graph, solve the equation here. Okay, where x is more than 0 because they are fractions, so the denominator cannot be 0. How do I solve such questions? Okay, so very simply, even though it may look hard, we will do it step by step. I'm given this equation here. What I want to do is to manipulate this equation such that I'll get something like this form over here, which is the graph that I've drawn. Because you have to use your graph. So if the question says use your graph, you must somehow manipulate this such that you can get your vertical intercept to be y minus x, your x-intercept to be x squared. So what I can do to this equation here is to multiply by x squared throughout this whole equation. I will get y minus x equals to x squared plus 10. Okay, so therefore, by multiplying x squared throughout, I'll get this equation here. And therefore, I can see that this is your y-intercept. This is your x-intercept. Okay, and this equation can be written in the form of y equals to mx plus c. And from here, I can therefore see that I need to draw a line. Need to draw a line on the graph below where the gradient of this line is equal to 1 and the vertical intercept is 10. Okay, so very simply over here, to draw a line based on this table of values, very simply, we will draw a very short table of values here. I'll draw this table of values at the side here. Okay, I know that my y-axis is y minus x, the x horizontal axis is x squared. Okay, so I want to solve this equation here. I need to draw a line on this equation on the graph. So therefore, I will simply take any 3 points that can be drawn on the graph. Okay, I'll just choose any 3 points. So let's say based on my x square range, my x square axis is from 0 to 30. So very simply, maybe I'll just take 0. Let's say I can choose 0, 10, 20. Okay. Then therefore I find out what is the corresponding y minus x value. I know that when x squared is 0, x is 0. Okay. So over here, based on this graph here, okay, when x squared is 0, y minus x is simply 10. Okay, which is your vertical intercept. When x squared here is 10, y minus x is 10 plus 10, which is 20. When x squared is 20, y minus x is 20 plus 10, which is 30. Okay, so now my last part is to draw this graph. Okay, I will draw the graph of y equals to x plus 10. But in this case here, my y is actually y minus x. My x is actually x squared. Okay, I'm going to draw this straight line graph onto the graph paper below. So based on this table of values here, okay, I can now plot out the points. Maybe I'll use a different color so you can see. Okay, so let's say for this part here, okay, I will now, based on these 3 points, I will now plot the graph 10, 20, 30. So when x squared is 0, the y-intercept is 10. When x squared is 10, y-intercept is 20. When x squared is 20, the y minus x is 30. Okay, so therefore this means that the straight line graph that I need to draw, oops, damn it, this one should be here. Okay, the straight line graph that I need to draw would be this line over here. Okay, so I've done this. I'll now label this line as well. This line has the equation y minus x equals to x squared plus 10. Okay, so very simply over here, how do I answer the question? By drawing a suitable straight line on the graph, solve the equation, this. Okay, so over here, very simply, by looking at this graph here, I can see that the intersection between these two graphs, it should lie, let me see, okay, it should lie somewhere, okay, maybe my graph is not that accurate because of the graph paper online, but the intersection point should be, let me label it, this intersection point here should be, okay, I should use a cross, this intersection point here, it should be 13, 23. Okay, if you read carefully based on your graph paper here, okay, so therefore the question here says solve the equation. When the question says solve equation means I want to find the value of x and y. So if I've drawn this suitable straight line on this graph here, okay, this tells me that the x square value here, okay, I write part B. This tells me that the x square value is equal to 13. The y minus x value is equal to 23. Okay, so how do I solve this from here? I can get that, therefore, x will be equals to plus minus square root 13. Okay, and in this case over here, take note, based on this graph here, we can see that x obviously is a positive value. So therefore, I reject x equals to negative root 13. Reject x equals to negative root 13 as x is more than 0. Therefore, x is equal to positive root 13. And therefore, I can now sub inside to find the value of y. So this means that y minus root 13 is equal to 23. Y will be equals to 23 plus square root 13, which will give me 26.6, round off to 3SF. Okay, and this is the answer to part B, to find the intersection points and the corresponding value of x squared and y minus x. Okay, and then I can from here solve for the value of x and y from here. Alright, so this is for example 1. Okay, feel free to pause the video if you need more time to write down the workings on your graph paper. Okay, we'll now move on to example 2. Okay, example 2 here. This question, let's look at this question here. We are told that these two variables are related by this equation here. This equation contains an exponential with an unknown power, whereby a and b are constants and are given x and y values. Draw a straight line graph of log y plus 4 against x. So very simply over here, before I draw this graph first, my first step, I go back to the steps again. The steps to draw any straight line graph from a non-linear equation: form the linear equation first, draw table of values, then plot the graph and with your axis written clearly. Okay, so I'm given this equation here. The question asks me to plot a graph of log y plus 4 against x. I do not see any log over here, which means my first step should be to convert this equation such that I can get a log y plus 4. Okay, so let's write out the steps over here. Okay, over here, I rearrange this equation. I'll get y plus 4 equals to ab power x. Okay, therefore, from here, to get log y plus 4, I'll take log on both sides. This is LG, so means log base 10. LG log 5, y plus 4 is equal to log ab power x. Okay, remember, I log the entire left side and right side. Then from here, by product law, I can continue to split this apart. This means log y plus 4 equals to log a plus log b power x. Therefore, this further means that log y plus 4 is equal to, by power law, I can bring down the x. It will be log b times x plus log a. And with that, I've written my equation into the form of y equals to mx plus c. Okay, so if I highlight the corresponding values, now the y-axis will be log y plus 4. Okay, the x, just x will be my x-axis here. The gradient, log b will become m. Log a will be the vertical intercept. Okay, so therefore, I've now rearranged this equation. My next step is to draw the table of values. So how do I draw a table of values? Same thing again. Based on this table of values here, I need log y plus 4. I already know the x. So that means in this table here, I must have one additional row to say log y plus 4. So let's write this into your graph paper now. Example 2. Okay. On the top right side, you can write out the table of values here, the x and y values, and then you calculate yourself. Can you try this by yourself first? Make sure you know how to press in your calculator to calculate log y plus 4 based on the corresponding y values. Okay, I will now write out the answer since I've already calculated them. 0.778, 1.079, 1.380, 1.681, 1.982. Okay. Okay, so I've now plotted my table of values. My last step is to now draw this graph. So therefore, I just need to check carefully based on this table of values here. When x is 1, log y plus 4 is 0. So you can draw your axis as such. This is how I draw my axis based on what I need to follow. Okay, my x values are just from 0 to 5. And my y value is all the way up to, in this case here, up to 1.982. So I'll put it up to 2.0. Okay. Okay, so remember to read the question carefully. The question tells you that over here, 1 cm is to 0.1 unit on the vertical axis, 2 cm is to 1 unit on the horizontal axis. Okay, then once you have done that, you can now plot your points based on the graph here. I have x equals to 1, 0.778. Okay, so over here, I should get okay, 2 is 1.079. Okay, you can do an estimation. It may not be the most accurate. So you will need to estimate based on your graph. Okay, 1.380. Okay, 4 is 1.681. Okay, last one is 5 is 1.982. Okay, alright, so I've plotted my points. If I draw a straight line graph to connect them, I should get something like this. Okay, is my line accurate? Let me see. Okay, I should probably get a line like this. Then remember, once I've drawn this line now, I'll label this line. This line has the equation of log y plus 4 equals to log bx plus log a. Log b times x plus log a. Okay, this is the equation of the line. Okay, so now part 1 is done. Part 2, now use our graph to estimate a value of a and b. So if we correspond to this graph here, log b represents your gradient, log a represents your vertical intercept. Okay, so for part 2 here, okay, let's do part 2 now. Based on this graph here, okay, part 2. Part 2, okay, log a is your vertical intercept. My vertical intercept is 0.48. So that means that over here, log a is equal to 0.48. Therefore, a is simply 10 power 0.48, and I can calculate this to 3SF. It will be 3.02. Round off to 3SF. Okay, then next part, I know the gradient of the line is equal to log b. Okay, so over here, this means that to find the gradient first, I must draw my gradient triangle. So based on this graph here, I can estimate a gradient triangle here. Maybe I'll draw my gradient triangle first. Remember to draw a gradient triangle. Okay, I'll get I'll choose this point here. Okay, maybe about here. Let's see. I must find a nice point. Okay, this point looks okay. Maybe this point here. Okay. And then I find remember your gradient triangle should be more than half the length of the triangle. Okay, so over here, gradient, I can maybe take 0.6 here. Okay. Please use a ruler, unlike me, which I don't have ruler right now. Okay, this is my gradient triangle. Then now I mark out the coordinates of the points I've chosen. This one is 0.4, 0.6. And the top part of this line, this is 4.5, 1.82. Okay, so therefore, I know that from here, log b is simply equals to gradient y2 minus y1, 1.82 minus 0.6 divided by 4.5 minus 0.4. Okay, so now I'll calculate this into my calculator. 1.82 minus 0.6 over 4.5 minus 0.4. I should get, in this case, this is as a fraction, I'll get 61 over 205. Okay, so therefore this means that b is simply 10 power 61 over 205. I should get my final answer here. Let me calculate. 10 power 61 divided by 205. I get 1.98. Okay, usually there's a plus minus 0.5 margin of error for calculation of a constant based on a graph. Okay, so remember please make sure this is your best fit line. Then you can calculate this a and b more accurately. Okay, so this is for part 1 and part 2. The last part now, okay, let's look at the last part of the question. By drawing a suitable straight line on your graph, now solve this equation here. Okay, so over here, let's write out the equation. The equation I'm given is AB power x equals to 1 over 10 power negative x. Okay, if the question is hit by using your graph, you must find a way to manipulate this equation such that you can obtain a log y plus 4 and your x. Then you can draw the line onto your graph. So how do we do that? Let's do some analysis. Okay, I know that from if I were to look at this over here, okay, what can I do with this equation here? Okay, so based on what I was given, my original equation, I'm given, let me write, given, original equation is y equals to AB power x minus 4. Okay, so this means that AB power x is equal to y plus 4. Now I'll sub AB power x back into this equation here. Okay, let me put this different color. Okay, so I'll sub this value inside here. This will give me y plus 4 is equal to 1 over 10 power negative x. So therefore, from here, if I were to take log on both sides, log y plus 4 is equal to log 1 over 10 power negative x. Okay? Therefore, this means that by power law, I can bring down the x. Log y plus 4 is equal to x times log 1 over 10, the whole thing power negative 1, which will give me log y plus 4 is equal to log 10 times x, which is simply because 1 over 10 power negative 1 is 10. Log 10 is 1. So therefore, log y plus 4 is equal to x. So this means that from here, this means that I need to plot a graph of, okay, from here I need to plot graph of log y plus 4 equals to x. If I were to compare this, y equals to mx plus c, I can see that where, for this graph here, where gradient m is equal to 1, the vertical intercept is equal to 0. Okay, because here is an invisible 1, then there's nothing at the back, which means my vertical intercept is 0. Okay, so once I've figured that out, my last part now is to draw the table of values. To draw a straight line, I just need 3 points. So I can draw a simple table of values over here. Table of values. Okay, then now I'll plot x and log y plus 4. Okay, then how do I decide which 3 points do I need to draw this straight line here? I'll look at my x-axis first. I look at my graph here. My x-axis, the range is from 0 all the way to 5. So you can just pick any 3 points along this range here. Let's say I choose to use 0, 1, and 2. Okay, the corresponding log y plus 4. How to get this corresponding value? Okay, remember I'm plotting this equation here. So that means that when x is 0, log y plus 4 is also equals to the x value. So when x is 0, log y plus 4 is 0. When x is 1, log y plus 4 is also 1. When x is 2, log y plus 4 is also equals to 2. Okay, so therefore I can very simply, based on this table of values for the straight line, I'll now draw my straight line now. Okay, so over here when x is 0, log y plus 4 is 0. When x is 1, log y plus 4 is 1. When x is 2, log y plus 4 is 2. Okay, then now I'll draw my straight line that connects these points together. I should get this line here. Okay, therefore once I've gotten this line here, I go back to my graph. I try to identify what is my corresponding, solve the equation here. So that means I want to find the value of x. This equation, the only unknown is x. So what is the value of x such that these two lines intersect? Okay, I look at my graph equation. The corresponding x value, which is the intersection, is roughly about, I draw a dotted line down, is roughly this point over here. And this value of x would be simply 0.7. Okay, so last part for part 3, the answer to this question is simply x is equal to 0.7. Okay. And with that, we have done example 2. Alright, so now let's move on to example 3. Example 3 over here, okay? Okay, before that, there is one part that we need to go through first. To find the gradient of the line, why do we need to choose 2 points instead of using the values in the table? So the reason why we must draw the gradient triangle, you see every time I must draw a gradient triangle first, then I can find the gradient. The reason why I must do that is because, you can write down also, okay, the best fit line may not pass through every single plotted point. Okay, so therefore it's important to choose 2 points lying on the best fit line to find the gradient. One of the 2 points can be the intersection between the line and the vertical axis. So take note here, when we calculate gradient, I should only use points on the best fit line because some plotted points may not pass through the best fit line. So I hope that, please write this down to your notes here. This is an important point to note when we want to calculate gradient in this chapter. Okay. Alright, so now let's look at example 3 now. Example 3, a cuboid of volume V has the height x cm and a base of this. And the corresponding values of volume and height is given by this table here. By using suitable variables, on the graph paper, draw a straight line graph that can link this. Okay, so over here, I know that for any cuboid, I know that the volume of a cuboid is simply equals to, part 1, okay, volume of any cuboid is simply equals to base times height. Base area times height, which is, in this case, x times px squared plus q. Okay, so over here, by simply manipulating this equation, I want to obtain a straight line graph. I can see that if I divide by x on both sides, I'll get v over x is equal to px squared plus q. And now I have my straight line graph, which is y equals to mx plus c, whereby v over x is now my vertical axis, x squared is my horizontal axis. Okay, they will correspond as such. Okay, so that means once I obtain this form here, I know that we can write down very clearly y-axis is simply v over x, x-axis is now x squared. Okay, so over here, now I will move on to now draw my table of values. So you should be able to get your table of values from here. The question here, I have x and v. I must find the corresponding v over x and x squared values. So by calculation, I should get, I already calculated values already, so I should get 25, 100, 225, 400 here. Okay, then v over x will be simply 35, 65, 115, and 185. Okay, so these are my table of values. Then now I can draw the graph. My axis should look something like this. Okay, this one you have to decide the axis by yourself. So if you were to use the table of values to estimate how long of the line you need, you should be able to get something like this. Okay, then once you're done so, you can now proceed to draw the graph. Okay, so for the first part here, draw the graph, simply need to plot the points. So over here, I will plot the points. V over x, 35, x squared is 25, 35, 25, 35 here. 100 is 65. Okay. 225, I get 115. 225, I get 115 here. And 185, I get 400. 400, I get 185, so I get 185 about here. Okay, so therefore if I were to draw my straight line now, I should get a line that looks like this. Okay, I should get a line that looks something like this. Let me see. Okay, let me shift the line down. Best fit line, something like this. I think this is accurate. Yeah. Okay. So once I've drawn the line, my last step is to label this line. This line has the equation of v over x equals to px squared plus q. Okay. Then now the first part is done. Okay. So for part 2 now, use your table of values to explain, calculate the values for x for which the cuboid is a cube. So over here, part 1, we have to find the value of p and q first. Okay, so since that p is the gradient of the line, q is your vertical intercept. So very simply, from here, we will find the gradient of the line by drawing a gradient triangle first. Okay, so over here, gradient of the line, let's choose 2 points. I will pick, let's say, maybe I'll pick this point here. Okay. And perhaps this point. Okay. So please use your ruler. Based on your line, select 2 nice points that you can get the data from to calculate what is the gradient of the line. Okay. So this is my gradient triangle. This point here is 40, 40. Okay. Then over here, this point here is 340, 160. 60. Okay. So therefore, this means that for the part 1 here, maybe I'll write my part 1 answer. Where should I write it? Maybe I'll write it over here. Okay. Part 1 answer. Okay. Gradient. Okay, is simply equals to, over here, 160 minus 40 over 340 minus 40. I should get 0.4. And I know since gradient is p is equal to 0.4. Okay. Then the next part here, y-intercept. I see that y-intercept is roughly about 25. This value here is roughly about 25. Okay, so over here, this means that based on my graph as well, Q is equal to 25. Okay. Then the next part, okay, explain using our values of P and Q. So now based on my part 1 here, okay, I know that V, I sub in the values, okay. Over here, V is equal to x times 0.4x squared plus 25. Okay. Now, calculate the values for x for which the cuboid is a cube. For this to be a cube, okay, it means that I want to get my volume here. If it is a cube, volume of a cube is x cubed. Okay, length times breadth times height, and they're all the same value, equals to x over 0.4x squared plus 25, which means that I divide both sides by x. Since x cannot be 0, x squared is equal to 0.4x squared plus 25. Therefore, this means that 0.6x squared is equal to 25. I subtract 0.4x on both sides of the equation. Okay. This means that x squared will be equals to 25 divided by 0.6. I'll get 125 over 3. Okay. Therefore, let me make this smaller so I got more space to write. Okay. Okay, therefore from here, this means that x will be equals to plus minus square root of 125 over 3. Therefore, final answer, x should be equals to square root of 125 divided by 3 equals to about 6.45 cm, round off to 3 SF. Okay, and I'll reject the negative value. Reject x equals to negative 0.125 over 3 as x is more than 0. Okay, and this is for part 2. Okay, last one, part 3. Part 3 here. Explain how another straight line can be drawn on your figure to estimate the value of x for which the cuboid is a cube. When it is a cube, the volume is x cubed. Okay, which means that based on my graph here, if I were to manipulate this equation, I will have v divided by x is equal to x squared. And now I've obtained back to the form of the graph that I've drawn, which is v over x against x squared. Okay, so over here, remember this is the original line that I drew. Okay, the vertical axis is v over x, the horizontal axis is x squared. So that means for this question here, all I need to do is plot, let me use a black marker, okay, plot graph of v over x equals to x squared. If I were to compare this to y equals to mx plus c, okay, I know that my gradient in this case here, m is equal to 1, c will be equal to 0. Okay. Therefore, you just need to do your simple table of values. To draw a straight line, you just need 3 points. Okay, so to draw the table of values here, I'll get x squared and v over x. Okay, since my table of values here, x is from 1 to 5, I can just choose, let's say 0, 1, and 2. Okay, 0, 1, and 2. So when x squared is 0, v over x is 0. When x squared is 1, v over x is 1, etc. 0, 1, 2. Okay, so therefore last part is to plot the graph based on this graph here. Okay, when x squared is 0, v over x is 0. When x squared is 1, when x squared in this case is 1. Okay, instead of there's no 1, sorry, this one I should choose, since my x value is from 0 to 400, maybe instead of 1 I'll choose 100 instead, and 200. Okay, so that I can plot these tables more values more easily. I choose 100 and 200. Okay, therefore my v over x will be simply, when x squared is 100, my v over x will be 100 as well. 100. When x squared is 200, v over x will be 200 as well. Okay, so now I plot my table of values here. When x squared is 100, v over x will be 100. I mark a x here. When x squared is 200, v over x will be 200. Okay, then now I plot this line. Okay, I plot my line something like this. Okay, and this is the graph of v over x equals to x squared. Okay, and based on this, I have now drawn the line and hence verify the value of x found in part 3, part 2 over here. So if I were to analyze this graph here, I can see that based on this graph here, over here, okay, I look at the intersection points, I can see that they intersect at maybe about 45. Maybe draw a marking here. The intersection here is about 45. Okay, so this means that for part 3, for the last part here, x squared is equal to 45. So therefore, to verify the value of this, I just need to square root 45. Okay, to get square root 45, I will get x will be equals to 6.71 cm 3SF. Okay, they are, so if I were to compare those two values to verify it, using my graph, I get 6.71, 6.45. They are not exactly, they are somewhat close by, so therefore it should be accurate. Okay, as because this is a best fit line and also drawn, your graph, the accuracy really depends on your best fit line. Okay, so over here you can see that the values are close and similar, so therefore they should be accurate. Okay, so this is for the last part of example 3. Alright, so let's move on to the last question, the last example for this worksheet, example 4. Okay, for example 4 here, I am given this equation here, t equals to km power a. Okay, plot the graph of log t against log m. So very simply, step number 1, rearrange this equation. T Okay, rearrange this equation here. T equals to k m power a. To get log t, I'll take log on both sides. Log t equals to log k m power a. Log t is equal to log m plus log k plus log m power a. Okay, and by power law I can bring this down. I'll get log t equals to a times log m plus log k. Okay, so therefore I've now obtained my form of y equals to mx plus c, whereby it is a graph of log t here against log m. Log m is your horizontal axis. Log t is your vertical axis. Okay, which means that a is your gradient, log k is your vertical intercept. So now once I've drawn this graph here, I can now draw the table of values. So now fill in the table of values into your graph paper over here. Okay, in the top right side, I'll now fill in the table of values. I'll simply calculate from here. Okay, 2SF is sufficient in this case. Negative 0. Okay, so you calculate out the corresponding log m and log t values. Negative 0.22, 0.08, 0.26, 0.62, 1.00. Okay, then the corresponding values would be negative 0.22, negative 0.05, 0.11, 0.34, and 0.60. Okay, so therefore if I were to plot my axis, it should look something like this. And now I plot my points. I should get let's see, negative 0.22. I should get something like 1 point here. Oops. Okay, 0.08, negative 0.05 here, 0.26, 0.1126. Okay, 0.62, 0.34. Okay, then 1.00 and 0.60 here. Okay, so now when I plot my line of best fit, your line should look something like this. Okay, maybe I should shift this down a bit more. Okay, yeah, I think this looks like my line of best fit here. Okay, something like this. Okay, whereby there should be even points on the left and right side of the line. Okay, maybe I can shift this a bit more to make it more accurate. Yeah. Okay. Alright, so once I've done that now, I can now go and look at the question again. From here, use your graph to estimate a value of k and a. A is the gradient, log k is your vertical intercept. So for part 1, very simply, remember to label the equation of the line also. This is log t equals to log m plus log k. Okay, so over here, part 1, gradient. To find gradient, you have to identify your gradient triangle as well. So over here, based on this diagram here, I can see that my gradient triangle probably can be this point here. Remember, your gradient triangle should be more than half the length of the line, up to maybe probably about my vertical intercept. Then I can choose these 2 points. Okay. Okay. Please remember to use a ruler for this part. Okay, so I label the points. This is 0, negative 0.08. Okay, then this coordinate here will be simply 0.80, 0.46. Okay, so for part 1, okay, part 1 here, gradient. Okay, part 1, gradient is simply equals to 0.46 minus away negative 0.08 divided by 0.80 minus 0. Okay, so now let me calculate this value here. 0.46 minus negative 0.08 over 0.8. I get A to be equal to 0.675. Okay, this is for my gradient. Okay, then last part, the y-intercept here, k. Log k is equal to the vertical intercept, which is negative 0.08, which means that k is equal to 10 power negative 0.08. I should get k to be equals to 0.832, round off to 3SF. Okay, this is for part 1. Okay, sorry, this is for part 2. Okay, part 2 here, finding A and K. Alright, so the last part here, assuming that transfer of heat is constant, estimate the time it takes to cook 25 kg of stuff. So over here, based on this diagram here, okay, to cook 25 kg, it means that M is equal to 25. Okay, so over here, very simply, to solve part 3, maybe I can work out over here. Since I know that, A equals to 0.675, K is equal to, since K is not a nice number, I'll leave it as 10 power negative 0.08, 10 power negative 0.08, and now the M is equal to 25. How do I solve for T? Okay, T is given by this equation here. Okay, so therefore, very simply, T is equal to 10 power negative 0.08 times M 25 power 0.675. Okay, press this in your calculator, you should get a final answer of 7.31. And take note, time, T is given by hours, the units. So therefore, answer the question. Therefore, it takes 7.31 hours to cook the food, to cook 25 kg of the food stuff. Alright, and this is the last part of example 4. So let's just finish this up by looking at some questions over here. Very simply, do you think you'll get the same values of K and A if you were to use ln instead of log? The answer is yes. Okay, you will get the same values. It's just that your graph may look slightly different, but eventually when you calculate when you use the gradient and the vertical intercept, your answer should be the same for K and A. Okay, even if you plot ln T against ln M, the answer should be the same as well for the time taken. Okay, it will not change because your values of M and T correspondingly are still the same. Okay, and if you take log to other base, like let's say instead of ln which is log base E or log which is log base 10, I take any other base, you can also do that, but it will become very hard because you may find it very hard to calculate this in your calculator. That is why we usually use log base 10 or ln which is log base E. All this can be easily calculated in your calculator. Alright, so that's all for all the example questions in this worksheet. Once you're done, please go back and try the practice questions, which will be gone through in class after you have practiced all these questions over here. Alright, so please finish up practice question 2. Okay, and we'll continue more in class. So this will be the end of the worksheet for linear law worksheet 2.